Hello, I'm going to share to you how to tackle these questions. So it's actually typical of IGCSE questions. So it says that we are going to study the characteristics of phosphorus. Phosphorus in the form of P4. Okay, so P4 is basically is a molecule, atomic molecule of phosphorus. Okay, so this is actually phosphorus. The molecule for sulfur is actually S8. Okay, for sulfur is S8, and then for chlorine is actually CO2. Okay, so you already get this molecule, right? So the form of the molecule. So from this table, it seems that melting point is quite low, but boiling point is very high. Why boiling point is very high? Because basically you have a network of phosphorus. Yeah, so there will be like network of phosphorus first. Then there's like bonding between one phosphorus to the other phosphorus. Okay, so making it more energy needed to remove this bonding between phosphorus and the other phosphorus. That's why it has a high boiling point. And then it says that electrical conductivity is non-conductor, of course, because this one is a um, non-metallic. All right, and then solubility in water is actually insoluble. So the question is here, name type of bonding. So it says that type of bonding. So we have a ionic bonding. All right, we have a covalent bonding, and we have a metallic bonding. All right. So please bear in mind that if you see your periodic table, um, the positions of phosphorus is in group 5. So remember, group 1, group 2, group 3, and group 2, group 5, 6, and 7, they tend to form ionic bonding because group 1 loses 1 electron, group 2, 2, and 3. This is loses 3, group 5 gains 3, and group 6 gains 2 electrons, and group 7 gains 1 electron. So this process is actually transferring electrons, so that's why um, ionic bonding. But then because phosphorus is located in group 5, and then we have a bonding like this one, okay, so meaning that the network of phosphorus will tend to give you covalent bonding. So when you encounter questions in IGCSE, you need to find the keyword. So what the questions wants you to write in your answer, okay? And next, explain in terms of attractive force, all right? Uh, between particles of P, right? Why it has a low melting point. Okay, so when you come to answer low melting point, please direct your attentions to the forces. Okay, so forces what? Forces of attraction. Okay, so if the forces of attraction between molecules, all right, between molecules is are weak, then definitely you may expect for low melting point. All right, so remember, melting point of non-metal is different with the factors that affect the melting point of metal. The factors that affect melting point for non-metal is actually the attractions between the molecules, but the thing or the factors that affect melting point for metal is actually the strength, okay, strength of metallic bonding. Metallic bonding. Okay, so remember, yeah. All right, so next, let me discuss these questions. Explain why phosphorus is non-conductor of electricity. All right, so if we talk about conductivity of electron, all right, in the lattice structures of metal, all right, so if we discuss, we have a metallic bonding, for example, if this is one first layer, this is the second layer, and this is the third layer, and then we have a sea of moving electron like that. So the electron, which denoted in red ink, okay, so red color, so these electrons move, okay, when this electron moving, so there will be electricity, All right, so okay, so in order to address this question, so we have to consider it is because no free, okay, electrons. If no free electrons, so no electrons moving, right? So it will be a non-conductor um, substance. All right. Next, phosphorus reacts with air to produce P4O10. Write the chemical equation. So phosphorus is P4, and in the air we have O2. We have also nitrogen gas and the other noble gas, right? Noble gas component. All right. So assume that we have O2. All right, because you have oxygen here, and then it becomes P4O10. All right, so you only need to balance because you have 10 oxygen on the right hand side. Initially you have 2, so 10 divided by 2 is actually 5, while the number of phosphorus is already balanced. And then what type of chemical reaction? So the type of chemical reactions can be combustion, right? All right, can be also redox reaction. Okay, why redox reactions? Because the oxygen state of phosphorus increases, or in this case phosphorus on the left hand side you don't have oxygen, but on the right hand side you can see phosphorus gains oxygen, 10 oxygens to give P4O10. So you may say that this is actually redox, or you can also say that this is actually the combustions of phosphorus to give phosphorus 5 oxide. All right, next is let me erase this one. All right, so phosphorus 5 oxide forms of acidic oxide. I'm going to tell you, listen carefully. If you have a non-metal, so this is our agreement. For non-metal oxide, okay, it always gives you acidic oxide, okay, acidic oxide. Meanwhile, if you have metallic oxide is actually basic or alkaline oxide. Okay, so metallic oxide comes from group 1, group 2, group 3. For example, MgO, all right, or Li2O or Al2O3, all right. But Al2O3 has a distinctions, yeah. So because this one can be in the form of acidic or basic, which is called amphoteric. All right. So because P is in group 5, so you will have a non-metallic oxide, then it's actually acidic. Then it will give you P4O10 3 minus. All right. So write the chemical equations for the reaction between phosphorus dioxide and aqueous sodium hydroxide. So what you need to write is actually P4O10. Okay, you add NaOH. So in your mind, you think that this PO4 will be in the form of PO4 3 minus. All right. So think in something that you have a PO4 3 minus. Well, you can split this one, Na plus 1. Why Na plus 1? Because Na is in group 1. And then you also have OH minus because OH is negative 1 charge. So what happened is actually you can put them together. All right. So there will be like substitution reaction, and then you will have another H plus here. So you have a H plus, okay. All right, so because it says in water, okay, so you have H plus, and then it will get this OH, so OH will attract it to H plus. All right, so now what is the product? So you have an Na plus, and then you have PO4 3 minus, Na plus and PO4 3 minus. So what we need to do is you transfer this 3 here, okay, and then you have 1 here, 1 plus, and you give to PO4. So Na will gain 3, and then PO4 gains 1. So that's why you will have Na3O4. Okay, Na3PO4, and then of course you have water. Okay, so you only need to balance this reaction. Okay, so if you balance this one, then I have a 3 here, Na, right? And then I have a 6 here, and then I have a 4, and then I'll just put here 12. Okay, so you can balance this fraction easily Um, next is let's talk about this one. All right. Complete the dot and cross diagram. So it means that you may choose one actually dot and the other one is cross. All right. So you only need to do is actually go to see your periodic table. Where is phosphorus located? Okay. So phosphorus is located in group 15 or group 5. H in group 1. All right. So it means that you have a 5 electrons in phosphorus. That's how you do it. So easy. So you just do like clockwise 1, 2, 3, 4, and 5. Why I put here? Because I need to share these electrons of phosphorus to hydrogen. And then you say that a hydrogen in group 1, meaning there is 1 electron in the outer shell of hydrogen. All right. So you'll have a 1 here, 2, this actually dot, and then okay. So now I have these arrangements of pH3. Okay. Again, yeah, you only need to see your periodic table. Where is this atom located? Then the group of that atom is actually the number of electron in the outer shell. For example, if you have a Cl, okay, and then you have O, all right. So you will have O is actually in group 6, so there will be 6 electrons of oxygen, and then there is 7 electrons of chlorine. So then you'll have O, 1, 2, 3, 4, 5, 6, and then the other one is actually for chlorine. Then you'll have a 1, 2, 1, 2, 3, 4, 5, 6, 7, and 8. So you have a complete. So 1, 2, 3, 4, 5, 6, 7. So we have a 7 electron here. And 1, 2, 3, 4, 5, 6, and 7. So you'll have this structure. Okay. All right. That's how you do it. Next is phosphine has similar chemical structures as NH3. Okay, what's mean by base? Base, by definition, is actually you only say that base proton acceptor. Okay, proton acceptor. Why it says proton acceptor? Watch this one. When you consider pH3, okay, so NH3 for example, then you'll have a 1, 2, 3, 4, 5, and then I have a H1, 2, and 3. Okay, so if I draw the dot and cross for NH3, then definitely I have this lone pair of electron, because one lone pair of electron, and this lone pair of electron can be it is actually potentially to accept proton, which is H plus. H plus means that H that has no electron, so actually 1s1. Okay, so if this electron is no longer there, so meaning that H plus is without electron, so N will accept this proton because it has a lone pair of electron. Therefore we may say that base is actually proton acceptor because this ammonia accepts proton. All right. Now, lastly, write chemical equation between ammonia and sulfuric acid. So because this one is base and this one is acid, then you have a salt and water. Okay, so ammonia plus sulfuric acid. Okay, so think about in your mind, you have a NH plus and OH minus, and then you have H plus and SO4 2 minus. All right, so think that you have this together, right? And then you have another one is actually together. Okay, so you have a NH4 plus and then SO4 2 minus. So you just change this one. Okay, give 2 to NH4, 1 NH4 to give to SO4, then you have NH4, NH4 again is 1, and then, excuse me, sorry, so NH4 gains 2 from SO4, then you'll have a NH4, 2, SO4, okay, NH4, 2, SO4, and you have water, okay. But then you can just balance this one directly. All right, so I can put here For ammonia, I can put 2, and then that's it. I think it's already balanced. All right. So that's all from me. So if you have any clarification or questions, you can ask. And then thank you for watching this video.